We're gonna try this out on the stretch of road here. This is my 2004 GMC 2500. Last week in class, we determined that the diameter of my tires is 2.4 meters, which simply states that every single time one of my tires rotate 360 degrees when it makes it all the way around, that my vehicle will have traveled 2.4 meters. So using that fairly simple, which I think was simple, but after you get onto it, it's simple, tire calculation, you can then start to figure out some other things, like possibly how many times my tires rotate in a kilometer, and maybe do some reverse calculations, because normally I would just drive down the road and my tachometer there would just tell me how many RPMs we're going at. But if we were to reverse engineer this, we could use the values off the vehicle to figure out how many RPMs my truck really runs at. So we're going to do a little video here from dead stop, and we're just going to show the 4-speed automatic transmission shift. I'm not going to reach 100 kilometers per hour here. I'm in first gear. I felt second. I felt third. Can't really tell if I hit fourth or not. Okay, that's under a light throttle application. The vehicle sensed that I didn't really want to rev up the engine very much. I wasn't asking for a lot of power, so I got what I got. Now I'm going to give it a little bit more power. There's first gear. Second gear. Okay, and you can see the difference in, depending on how much throttle you give it, how your vehicle is going to react. I'm very careful not to let this vehicle get into fourth gear for the purpose of this video and the answer that it would give away. Okay, right now I'm driving along in fourth gear, presumably that's what I'm in. I'm going to just manually shift down into third. So there's third. You can see the RPMs jump. I'll just go back. Unless you weren't paying attention, you can see the difference in RPMs. And we last week calculated or found all the gear ratios on ProDemand for this transmission. So third gear was 1-to-1 ratio. So the engine speed is matching the transmission's output shaft speed right now. And then fourth gear was 0.75 to 1. One more thing that we did last week was we figured out the ratio of low in the transfer case. So just to display what that means, I just wanted everybody to understand. I think the question was, I think I told you 2 high was 1-to-1, and then I asked you what 4 low and 4 high was, and people got very confused. Well, 2 high is the same speed as 4 high, but I'm just going to engage all 4 wheels. But 4 low is different. I'm going to hit 4 low. I don't know if my truck's going to want to go into 4 low this morning. Sometimes when you just sit still, it has a hard time engaging that gear. So I'm going to put it in neutral. Yeah, there it goes. You even maybe heard the clunk in the video. I'm not quite sure. Okay. I'm going to show the difference in RPMs or speed or acceleration when I'm using 4 low. Okay. This is first gear. Now I'm going to rev it up. I'm in fourth gear. Starting to make a lot of noise here because I'm at 4,000 RPMs and just over 70 kilometers per hour. You guys looked it up on Protoman and told me that my transfer case low was 2.72 to 1. So that's over half as slow. Half as slow in low range. Now, just so you guys know that low range is actually, because of that low gear ratio and that planetary gear set it has to get in the transfer case, it's a little bit of a pain in the butt sometimes to get in and out. Yeah, there we go. It actually made a fairly loud clunk. I'll let these vehicles go by that are right behind me, including my local police detachment here. That's okay. Mechanics are constantly on their phones anyways, and scanners trying to fix things. So, I guess the $1 million question is what is my vehicle's engine RPM at 100 kilometers per hour with the factory 245/75 R16 tires? You guys are going to calculate that, and then I'll hit play on this video again. So that is the assignment, is to figure out what engine RPMs am I going to be at 100 kilometers per hour. So we're going to get there. Now watch very carefully. When I get into fourth gear, there's also one more factor that we haven't really talked about much, but we talked about it when we talked about torque converters, and that's a torque converter lock. Watch the RPMs. Okay, I'm gonna just get 100 here. Sorry, the road to Brandon's not really that smooth. It's pretty much 100 kilometers per hour and approximately 1900 RPMs. So that's the answer. 1900 RPMs. We're gonna stop one more time. So if you guys got around 1900 RPMs, you did pretty well. And you'll find that, you know, trucks are never really that simple, because if you went ahead and did all this hard work and you know, got your number of 1939 RPMs, 0.6, you'd be like, oh, I'm pretty proud of myself. I did a lot of work there to figure out that truck's going to run at 1940 RPMs or so. And that would all be lovely. You know, there it is right there, 245/75 R16. And you know what, after all your hard work, guys, I hate to break it to you, but I don't have factory size tires on my truck, so you can start all over again. That's a 235/85/16 right there. Okay, I hope you enjoyed this video, or hate math at this point.